Hello everyone, again. My name is Daria. I'm from Novelties, and today I will present you this exercise in QGIS, which will be dedicated to collapse of a Plateau glacier and consequences on snow and vegetation cover. So for this tutorial, there's also step-by-step PDF file and a video, because as we have not much time here today, I will not be able to present you in all details in how to use all the tools we use in this exercise. So if you want more details, more steps to follow, go to the website of this workshop and find this information there. So now I will just give a little context to the topic we're going to study. So we're going to look at collapse of Plateau glacier, and this was a collapse that happened actually this year in May 2025. It was on 30th of May, and that happened in Swiss Alps. And basically, in a couple of days, a full glacier, as you can see here in the photo, a full glacier, what was here, collapsed and brought all the debris, all the rocks, and mud down the couloir into the valley, and destroyed and covered the whole village. So I don't know if you can really see on the photo, but you also will see on QGIS that here there was a village with residents there, and well, in just a matter of a couple of days, it was fully destroyed. So such events, such as collapses of glaciers and melting of glaciers, they happen more and more often recently, because, well, we have climate change, right? And we have increase in temperatures that, of course, influence the melting process. The ice, it melts, and the most important is not only the ice that melts, but also this ice actually holds together a lot of rocks, because, well, we're in mountains, right? And exactly, if this ice does not exist anymore, all these rocks gonna collapse. And in the mountains, we have very often in the valleys we have settlements and some infrastructures. So it is getting more and more dangerous for people living in such areas. So for the data we are using today, it's basically, I'll show you, it's only one product, which is a Sentinel-2 images from a website, from a platform here. And well, the Sentinel-2 images, that's raster tiles. So basically we have a tiles that cover in different zones in different areas, and we are quite lucky for our exercise, because we only need one tile, because apparently only one tile covers our zone. Now I'll show you our zone, and we go to QGIS specifically. So, well, here is is a map like you see in Google Maps usually. And if we focus on our zone, and I lost it actually. It's quite small valley. Well, I'll see the images, but yeah, I'll show you. And we will use a satellite image, as I said, and we will look at specific bands, because, well, each satellite image has a true color image and also sub bands, which allow us to have different combinations and to see different indexes. For example, for this tutorial, we're going to use two indexes, which is normalized difference vegetation index and normalized difference snow index, using which we can explicitly see snow cover and vegetation cover. So let's start with the data. So we downloaded 4 tiles. Actually, it's here. We downloaded 4 tiles for covering our zone. And we decided to look at the dates before and after the collapse. So the collapse happened explicitly, I think it was actually 29th of May. And but unfortunately, well, as a satellite image, it also captures all the clouds. For example, we tried to find the images that are most representative for this exercise. But yeah, sometimes due to cloud coverage, we cannot have a very clear image. So for example, we have 4 dates, which is 10 of May, 15, 30, 18, sorry, and 30. So from 10 to 18, so these 3 days, it was before collapse, and 30, it was right after, so we can see already the consequences. So first product exploration is our true color image. So basically that's the images exactly how, well, we see it with like true color. And I think if I do that, I might actually see my zone. Well, yeah, okay, that will be faster. Okay, so here, this is our zone of interest. Here is a village, and here's exactly the Blatant Glacier. You can see there's a lot of snow. Well, May is still quite, there's still a lot of snow in Alps in May. Well, these images sometimes have very high contrast, so it might be, especially with the snow, well, snow reflects a lot of light. But here we can clearly see that on 10 of May, well, there's a lot of snow, and just snow basically. If we click on 15 of May, we already see here, like you see the difference. Here you see some rock fall start to appear, but also here you see in the couloir, it also start to go down to the, well, to the village here. And it is true that people start to notice the rock fall quite early, like around 15th of May exactly, but it was just a rock fall, it was quite usual. And we can see that on 18th, it's getting more present. And then we have a date 30. And here we see the whole consequences of a huge area covered with rockfall and already destroyed the whole village. So that's just to see, to like spot our change, spot our collapse. But the most important part is, of course, our analysis. So these were the images, true color images, and now we need bands. So what we did, we added the bands to our project. You can see it's again big tiles, and we have added here we have two groups for snow index and vegetation index, and we added 4 different bands. So it's B3 and B11 for our snow index, and there's B8 and B4 for vegetation index. If you need a bit more information about these indexes, how we calculated and what exactly they represent, you can of course search on the internet, but we also give some information about it in a PDF file for this tutorial. So when we loaded those tiles, we see that they actually cover a bigger zone than we're interested in, because we're really interested in specific small area. And in QGIS, it can actually take a lot of time to process raster files because we have high resolution, they're quite bulky and heavy. So first we cropped our tiles. So for example, here you can see one of the tiles being cropped. And to well, I'll just activate them all to show. Also, yeah, important note that we decided to focus only on 2 days, like in 4 dates of visual evolution, like we spotted it. But then we decided to focus on 10th of May to see how it was like untouched area, let's say. And then on 30th of May with all the consequences of collapse to have a comparison between the two. So that's why you have two dates for each band for like, so 2 times 4, we have 8 cropped images here. And well, cropped or clip. To do so, you can actually, to clip the image, if it's a raster image, you can go to raster layer here, and there is extraction clip raster by extent. So that's what we did. What we do is here, we chose each input layer, so each band, original band image. Then we added the clipping extent, which we defined manually by just choosing the zone around the collapsed glacier. And then you just choose to save it or not to save it, you run it, and that's what it results in. So if we look, first let's look at snow index. So here, well, you see that each band is actually in like more like grayscale, so which is not very like representative to us, but yeah, that's how a satellite sees in different bands. And what we want to do next is to calculate our indexes, and for that we use raster calculator, which is here in raster analysis. If you don't have this processing toolbox, how it's called, sorry, window here, sometimes it just does not exist, especially when you open QGIS first time. It's here with a little gear icon here. You click on it and it's there. So in raster calculator, this a very powerful tool in QGIS that allows you to basically combine different raster layers and to have more information out of it. So for example, here we could set an expression and then do some additional parameters, tune some additional parameters. And for us, I will just copy paste to save time. For us, the expression, for example, for snow index, I think, yes, this one, which basically the difference between third band and 11th band divided by the sum of them. And then you can also see that usually raster calculator tells you if it's valid or not expression. It means that it's good. You can proceed. So we did this 4 times basically to obtain our snow index and vegetation index, both for before the collapse and after a collapse. So here for snow index, this is before. And basically on the color bar, you can see that, well, white means it's covered with snow. Dark blue means that there is no snow. You can also see that the water sometimes reflects light in the same it's the same range as snow, so it can be a bit misinterpreted with snow. And if we look at 30th of May, you can clearly see that these zones were more white, and now it's, well, blue, and you can clearly see the outline of the collapse. But yeah, like in the valley, since there were no snow, also, well, collapse brought only rocks, so together they did not, well, it doesn't show us as a snow, so which makes sense. And another next step that we did is to actually, like, we can of course look at this before and after and compare, but to make it more representative, it's always nice to have a difference layer. So difference layer is basically a layer like snow index at 30th of May minus snow index at 10th of May, and to see that basically gives us like there it was a loss of snow, it was a gain of snow. So that we also do with raster calculator by just stating snow index 30 minus snow index 10, and it will give us this difference. Also, you can see that layers are a bit different in colors, but yeah, I'm not gonna explain the details. You can also see how to do that in a PDF file or in a video. So here, for example, we have a different layer in a snow index, and you can see that basically in red, that's all the snow loss. And in the blue, it's like just, well, nothing really happened, or snow gain even. We are more interested in this area, so we clearly can see here exactly this in red, this little pattern that corresponds to collapsed glacier. But you also can see that here on the slopes there have been loss of snow, but we know that it's due to, well, higher temperatures, snow melts. That's normal. It's also May. And we did exactly the same for vegetation index, and we adapted another color scheme. So basically in green means that there is vegetation, and in brown there's no vegetation. So you see where it was snow or it was water, it did not consider as a vegetation. This was before collapse, and straight after we can see that first we're again in vegetation because, well, as I said, snow melts, it reduces, so more vegetation appears. But also you can see, of course, the area of our collapse we study. Here it's clear, but it's much more clear than for snow index, for example. And we did the same the difference here. Again, you can see that in red it says it's loss of vegetation. You can clearly see here. And in blue, it's gain of vegetation. Yeah, you can see that here it was gaining in those 20 days of difference. So now, as we have these two differences, we see that, for example, in this difference, we see there the loss of vegetation. But for example, here, because it was snow initially, it did not catch vegetation. We don't know what's happened actually here, but we saw already visually that there was also change here. And Same for, sorry, for the snow. Here we see the loss of the snow, but here there was no snow. So there is like separately these two different layers give us information, but together they can give us much more information, and that's what we want to employ here. So for that, we want to filter our raster, as you can see here, and basically use again raster calculator. And for raster calculator here, we used an expression which I will show you because it's quite specific. So that was an expression that we used. Oh, sorry. So basically, here that's again we using raster calculator by choosing parts of one layer and another layer, which suits better our suit better to highlight the collapse area, and we combine together. So for example, for vegetation index, we decided that it should be less than this value, and for snow index, less than this value. These values were really chosen by trial and error method. I really just looked on the values of the pixels. I calculated more, like several layers to see which values actually correspond better to highlight this area. So that was used. And as a result, it basically gives us this two like binary raster layer with like black and white. And in white, there are all the zones with all the pixels that actually fall under this condition, and in black that are excluded. So here you can see clearly our area, right, we're interested in, our collapse area. And of course, there were some zones here that fell under, well, it means that here was a snow loss and here was some vegetation gain or vegetation loss, and together they combine, but we are not really interested in it. So for example, why we are doing this is to like combine these two indexes to see better our zone, our collapse zone, and also to not only look at it, like see that something happened, but also try to evaluate it in like numerical way. And for that, we need this layer to be vectorized. So we vectorize this layer, and for that, you can go to raster tab here, go to conversion, and there's polygonize raster to vector. And yeah, here you choose input layer, and then that's basically it. You run it, and when it's done, it gives us this, but actually it is filtered here. I will quickly remove the filter. So that's exactly how the output of vectorized layer, how it looks like. So basically it's the same image like we have a raster one, just now it is polygons, not pixels. So pixels with the same values were collected in polygons, you can see here. But we are not interested in the whole this image, and it's actually quite not that easy to interpret. So what we did is we filtered it. We right click on the layer, we go to filter, we choose the field and equal to 1. Because then we had this binary layer, we had 0 and 1. 0 means, well, everything that did not fall under condition, and 1 that did fall under condition. So like this, I will untick this one. Like this, it highlighted us all the zones with 1, so that had actually loss of vegetation and snow cover, or together or separately. And we can see that there are other polygons that did not, well, that did fall under this condition, but we are not exactly the collapsed area, collapsed glacier. You can also right click on the raster vector, on the vector layer and go to attribute table. And the attribute table will basically show you that you have many polygons you see with the same value, which is 1. And here, after we have it, we want to actually have only this specific area. And for that, we use this feature, select features. We click on it, and then we just click on this big one. And it basically highlighted this one polygon we're interested in. And you can see that actually, if you zoom, there are small polygons that are actually also might fall under under this collapsed area, but we decided to just simplify our task and just choose this one. And then when this one is chosen, it's just highlighted on the visually, but not saved separately. So for that, we would right click on our layer in which we chose this in this polygon. And we click on export and save selected features as, and it will suggest you to save it as a shapefile, which usually the format of a vector files we use in QGIS. You just give a name, you save it, and as a result, we have this new vector layer, which only consists of one polygon. If you open open attribute table, you will see that there's only one. So here, what you wanted to do, I need to unload, yep. So we have now our polygon of our collapsed area, and we wanted to check the its area to know exactly what's the area. And so that you can either use this little icon here, you just click, and in derived here you can see this specific area. Here you can see that it's, I think it's 3 square kilometers, I think. Yes, it is. And also another way to do that is to go to attribute table, and here you will, well, you don't have a column, you know, normally area column here. You just click on the field calculator, and you create a new field with area name, and you put an expression, which is basically, we'll copy paste it for you very quickly. It's an area like this, because QGIS already knows that there is an area subvariable kinda, and this means that you want it to be in kilometers, square kilometers. And the result is here, and if you compare the two, it's 3 square kilometers, a bit more, and here is the same exact number. The only difference is that when you do this calculated with a field calculator, it stays in a layer. It is saved in a layer, and even if you close QGIS, it will stay there. And here's just information, like more like you would need to click every time on this layer with this tool to see. And that is it. And just for you, for like some scale, I will double check, but yes, for scale, 3 square kilometers doesn't sound like much, right? But it actually corresponds to 400 football fields, which is actually a lot. And yeah, like this, we actually can, with these tools we use in QGIS, we actually can see not only the different steps, the different like stages of the collapse, but also can calculate the area to understand the scale of the event and how much damage it actually brought on this village and the valley overall. And that is it. It was a bit hectic, a bit fast because I don't have much time. But yes, I hope you enjoyed it, and I hope you learned something new. And yeah, please do not hesitate to replicate this tutorial, and also you can maybe add some more variables, more data and products from the platform to like overlap with temperature or precipitation or whatever, to make this study even more interesting and interactive. And of course, you can use this type of a study not only in this specific glacier or specific zone, but wherever you want in the world. Thank you.
Thanks a lot, Daria, for the nice tutorial. It was really interesting, and yeah, it's not an old. Sorry. Okay. I was lost with the question. Okay, so yeah, we have a few questions for you. So you mentioned it a bit at the end, but would this tutorial work with a glacier outside of the Alpine?
Yeah, exactly as I said just at the end of tutorial, that yes, you can use it outside of the Alps. Of course, the only constraint you might have is the data availability in specific zone you want to study, because well, if you have some product, well, there are no products for specific area in specific like mountains in the world, then yeah, that's going to be basically the only constraint. But yeah, all the methodology works fine with everywhere.
Okay, thanks a lot. So this question, I'm not sure I understand correctly. Could we use the notebook Gorner Glacier? So I guess, yeah, it would be a Jupyter notebook at the WEkEO for glacier outline definition rather than NDSI. If so, what is the reason that it's not used?
I'm not very aware of what the notebook Gorner Glacier Jupyter Notebook means exactly. Probably it's maybe some library or some tool that was developed in a Jupyter Notebook to do so. And maybe it works pretty well, better than Snow Index. Why it's not used? Well, because the main reason of this tutorial is to show how to work in QGIS. So, yeah, okay, I see. Yeah,
Yeah.
thank you. Persistent snow area. Okay, well, first, yeah, because if it is a specific thing to use in Jupyter Notebook, well, here the tutorial is about QGIS, so how to see it in QGIS specifically. And if you're talking about persistent snow area, there's also such a product on the WEkEO platform. Yes, I agree. But yes, we didn't use it because we wanted to show how to use, how to work specifically with raster images, with satellite images, because it's also a big, say, like a big part of data available in WEkEO. But you also can, as I said at the end of the tutorial, you can add some other products and some other variables, and maybe also like do the same kind of analysis with persistent snow area and see what's the difference, like how detecting it from satellite imagery and detecting it from persistent snow area will change your results.
Okay, thanks a lot. So I think that was clear enough because we received thanks in the Q&A. So. Okay, so this one, I think it's more of a comment than a question. I suggest using some combination of erode and delayed to include missing areas, while also removing isolated pixels for you thresholds in this case.
Yep, of course. Yeah, that's totally valid point. And as I said, again, well, I had only like 20 minutes to present, and the tutorial itself should also have some specific time bounds. But it is true that yeah, like we saw that there were some pixels that were outside of our main polygon. We decided to choose as for area, or they were the opposite, like the areas that we probably know is what was not belonging to a collapse. And of course, we can either like remove them or add them. And for that, you can, of course, like if you have more time, you can do that. You can select it by yourself, you know, like just by hand, or adapt the indices, add more indices, and yeah, it's just the question of timing and yeah, expanding this tutorial further.
Okay, thanks a lot. So we still have a few questions. So this one, I think it was at the end of the presentation. What was the question you were attempting to answer? If it was, what is the total area of change? Why is it important, and in what ways?
Yeah, for us, the question was to see, to like spot the collapse of a glacier by studying snow cover and vegetation cover. Both because, well, we are in the valley, so we have a vegetation cover in the valley, and we have a snow cover on the slopes. So to use these two indexes to be able to spot and to kind of estimate the area of a collapse, and yes, to receive a total area of change, yeah, as much as possible, as precise as possible. And why is this important? In what ways? As I said, there are more and more collapses like that happen. There are more like our climate changes, the temperature rises, and we have less and less glaciers. Our glaciers, which were even 20 years, were huge and beautiful. Now they do not basically exist anymore. And of course, here in that specific tutorial, it is important because of a collapse can actually damage the infrastructure and, well, habitat as well. And but yeah, there are more questions to that, of course, about water source and so on.
Yeah, I agree. And so for now, it will be the last question. I did not see the cloud masking. Would it not be challenging to work with snow cover without cloud masking?
Yes, and there are no cloud masking here because we chose already dates that do not have a lot of clouds on the images. Well, we do have it, but not on the zones we are interested in, not the zones we really look. So, for example, there are more dates available, of course, of Sentinel because I looked at, as I said, 10, 15, 18, 30 of May. So between 18 and 30 of May was a lot of time, we could actually see more evolution of this collapse, but we couldn't because all the images that were in between these 2 days, they were basically fully covered or almost fully covered, like you literally see nothing because of the clouds. So these images were just not selected because, I mean, even if we have an image with clouds, we cannot really like mask the clouds to see what was below it with the satellite images. And yeah, so that's why there's no cloud masking here. And yes, it would be challenging to work. That's the like point to address when we work with Sentinel-2 data, but we need to find the images available for our study without clouds.
Okay, thanks a lot. Yeah, I think it's clear now for this point. So we have another question that just popped in. What advantages does this approach have over current change detection, for example, with Sentinel-1?
And I'm not familiar with coherent change detection, so I cannot really tell. But of course, I mean, Sentinel-1 has a different type of data, which also can be useful for such studies, of course. Well, we just focused on a Sentinel-2 here in the tutorial, but yeah, I'm not sure I can answer more than that because yeah, I'm not familiar with that.
Okay, thanks a lot. I can hide this one. Okay, so yeah, plenty of questions coming one at a time. Can we use this in calculating other changes in the environment as long as we have raster data?
Yes, that's an answer is simple, is yes. As long as you have raster data for different whatever types of yeah, like you have the satellite images with different indexes, you can calculate other changes as well on a cover. Yes.
Okay, thanks a lot. I think that was the last question. Yeah, I saw one general question about if we can access the tutorial. So yeah, the tutorial will still be available on the website, so no worries about that. And we'll also have the replay of today if you want. Yeah, thanks again, Daria, for the presentation. Also, lots of kudos in the chat. So yeah, the
Thank you.
people really enjoyed the tutorial. Yeah, thanks again.